Okay, so we've got an object being dropped, bounces off, and we know it goes in direction minus A1, but we don't know anything about A. We've got to show it equals 6. And we use a dot product here, which is the first time this is cropped up. Now we know the direction of the slope, so if we think about it, let's just do another option here. If we've got any vector A, theta, and I'm interested in, this is B. If I make this a unit vector, okay, then I get A dot B is the magnitude of A times cos theta, because the magnitude of B would be 1. So what this will do will give me the distance, this component along this line here. And the reason why that's important is because I'm looking at this and down the slope, and this one down the slope and this way, and I know these two down the slopes are equal. So I'm going to do this one dotted with the direction of slope, which will give me this length here, or this force here. And then I'm going to do, or velocity, sorry, not force, velocity. I'm going to do this one also dotted with the slope, which will give me the velocity down the slope. So I'm going to do 0 minus 7 dotted with, now remember I want a unit vector, this is 3/4, this will be magnitude 5. So I have to do minus 4/5 and minus 3/5, and that must equal minus AI plus 1j dotted with the same vector, minus 4/5 minus 3/5. I can ignore the fifths because they appear on both sides. That times that is 0. I get 21. Here I get 4a. Here I get minus 3. 4a equals 24. A equals 6. For the second part, we're looking for the coefficient of restitution. So we're more interested in the velocities perpendicular to the slope. So we're going to do a similar thing, but we're going to use this vector, then this direction, because we're not interested now with dotting with that direction, we're interested with the perpendicular. So if this is minus 3 minus 4, then the perpendicular one, sorry if I get this right, so that's minus 4 minus 3. If I want to go perpendicular, I want to go that way, it's going to be minus 3, 4. Don't know very well, but minus 3, 4. Okay, the negative reciprocal. So rather than minus 3 over 4, I've now got positive 4 over minus 3. Okay, so I'm going to do a very similar thing. I'm almost exactly the same. I'm going to say, well, minus 6, 1, which I now know is the velocity afterwards, dotted with this perpendicular vector, minus 3/5, 4/5. So that gives me the component that is perpendicular to the plane. That has got the same magnitude as 0 minus 7 dotted with minus 3/5, 4/5 times E. Same magnitude, but clearly the opposite direction, so I'll build that in by putting a minus there, because this one is going away from the slope and this one's coming towards the slope. So here I multiply this out, I multiply everything by 5, so I don't need to worry about that. So I've got 18 plus 4, I get 0, I get 28e Divide by 28 is 22 over 28. So E is 11 over 14.